Hey there, and welcome. Have you ever thought about learning to code, but then kind of hit a wall thinking you need to be some kind of math genius to even get started? Well, today we're going to bust that myth wide open. We're diving into the idea that programming isn't really about complicated math, it's about learning a powerful new way to think. So let's just get right to it. Is programming a club reserved only for the mathematically gifted? And the answer is a huge, resounding no. The real secret, the key that unlocks everything, is actually something you're already an expert at: solving problems. Think of it like this. Learning a language like Python or JavaScript is kind of like learning the grammar and vocabulary of, say, Spanish. It's just rules and syntax. But the real magic, the thing that'll make you a great programmer, is learning how to structure your thoughts and break down a big challenge into small logical steps. It's all about the structure, not the formulas. Which brings us to, well, the secret weapon. We're going to call it the programmer's mind. And no, it's not something you're born with. It's a mental toolkit that anyone, and I mean anyone, can build. It's really the engine that's humming under the hood for every great developer out there. So what is this programmer's mind? Well, it's this amazing blend, right? You've got the creativity of a writer who can imagine a whole world mixed with the super precise, detail-oriented mind of an engineer who makes sure the bridge doesn't fall down. It's about being able to dream up the big idea and then build it piece by meticulous piece. And this quote just hits the nail on the head. Programming is totally an art. It's creative. You're making something from nothing. But it's also a science. It's quantitative. I mean, at the end of the day, your code either runs or it breaks. Simple as that. It either achieves a specific goal or it doesn't. And this slide just lays it out perfectly. So on one side, you're the novelist. You're seeing the big picture, the entire forest, figuring out what the user really wants. And then you've got to flip a switch and become the thermostat, laser focused on the details, the individual trees, executing a command that is perfectly precise. Set this room to exactly 22 degrees. Great programmers are constantly bouncing between these two modes. Okay, so that all sounds great, right? But how do you actually build this kind of mind? Well, the first step is getting your thoughts out of your head and down on paper. For that, we need a blueprint. The source material we're looking at has a great name for this: the cerebral graph. You know, one of the biggest mistakes beginners make is just diving right in and starting to type. It's like you wouldn't try to build a house without a blueprint, would you? Of course not. Your cerebral graph is that blueprint. It's your map of the problem and how you plan to solve it. And you create it before you write a single line of code. And building this map is actually pretty straightforward. There are just 4 steps. First, name everything. Give everything a clear label so you know what you're talking about. Second, draw out the problem. Then, sketch out a possible solution. And the last step, and this one is super important, is to break that big problem down into smaller, bite-sized pieces. It's that classic divide and conquer approach. All right, let's make this concrete. Let's say you're working on a smart home project. See, your cerebral graph isn't code at all. It's just questions. What stuff do I already have? Can it even be automated? Do I need one main controller or a bunch of them? How are we going to run the wires? Answering these questions literally builds your map and shows you all the little sub-problems you need to tackle one by one. Okay, so you've got your map. Now you need some tools to actually navigate it. And don't worry, we're not talking about crazy calculus here. These are simple, logical tools you already use without even realizing it. The absolute number one most fundamental tool in your kit is the good old if then else. This is the bedrock of pretty much all programming. It's really just a structured way of saying, if this thing is true, do this. Otherwise, do that. That's it. It's just making a decision. Like, check this out. If a car's speed is over the speed limit, then send an alert. Else, just do nothing. You and we do this stuff in our heads a million times a day without even thinking about it. Programming just gives us a way to write it down so a machine can do it for us lightning fast. Now, what if things get a little more complicated? That's where something like a decision table is a lifesaver. Look at the shopping example. This table just neatly organizes every single possibility. And you can see at a glance, there's only one single row where we actually go shopping, when we have money and the store's open. Suddenly, a tricky decision becomes as easy as just looking something up in a chart. And what's cool is that from these really simple building blocks, you can create way more powerful tools. Things like decision trees or finite state machines, which are perfect for modeling how a traffic light works. Now, don't get bogged down by the names. You don't need to be an expert on these right away, but it's good to know they're out there when you need them.
All right, this brings us to the last and honestly maybe the most crucial piece of the puzzle. Being a great programmer today isn't about building every single thing from scratch. It's about being smart and resourceful.
Here it is, the prime directive for any modern programmer. Deliver a working solution. Period. Your value isn't measured by how many lines of code you write. It's measured by how fast you can deliver something that works. This isn't just a philosophy, it's a business reality. Getting things done quickly and efficiently is what matters. And this is how the pros do it today. They are not sitting there reinventing the wheel every single time. Why would they? They use content management systems, low-code platforms, they grab free battle-tested code from places like GitHub, and they plug into powerful APIs and AI frameworks. A huge part of programming today is being a great assembler, a great integrator of these powerful pre-built parts. And I absolutely love this quote from our source material. You'll hear some old-school programmers kind of look down on these tools, call them easy. But that's just an outdated way of thinking. A smart professional uses the best tool for the job. Hey, if they want to ignore them, that's their problem. It's totally their loss.
So I want to leave you with one final thought. The next time you're staring down a big, complicated challenge, just stop for a second and ask yourself this. Is this really a coding problem? Or is it a thinking problem? Because 9 times out of 10, once you solve the thinking problem, the coding part, well, that's the easy bit. Thanks for tuning in.